In this section, we are going to look at recursive formulas. And recursive formulas should be a new topic for you that you have not really seen before. But this first term that we are going to look at is a sequence. And this is something that you may not have called a sequence, but you've certainly been familiar with. A sequence is just an ordered list of numbers formed by some pattern. So since very early grades, you have been seeing patterns like this, 2, 4, 6, 8, and so on. Maybe you were asked to fill in the rest of the pattern. So that is a sequence. So any list of numbers formed by a pattern is a sequence. A recursive formula is going to be a formula basically that tells us that pattern. It's a formula that defines each term of a sequence using preceding terms. So we'll look in more detail about that here in a moment. Recursive formulas can be related to explicit formulas. Explicit formulas is what we're more familiar with dealing with in algebra in general. Something like y equals 3x plus 4 is an explicit formula. It's a formula where you can use that you can use to find the nth term of a sequence there. That n could be any number. So it could be the first term, the 10th term, the 57th term. You basically just have to plug in the number to find that term. Some notation that we are going to use for recursive formulas, if we see a with a subscript of 1 right here, that's the first term or the number 1 term in the sequence. The second term would be called a sub 2. The nth term could be a sub n. The term that comes before the nth term is a sub n minus 1. And these are going to be used in our formulas right here. So let's look at what this is going to look like. So I used f of x and x here at the beginning for this explicit formula just because it is what the notation that we're most familiar with. So if I've got f of x equals 10 times 2 to the x, if I want to find a term for this formula, I just plug numbers in. So if I plug in 0, like it asks here, 10 times 2 to the 0 power would give me 10. And then I could do that with 1. 10 times 2 to the first power would give me 20. And then 10 times 2 to the second power would be 40. And just really quickly, I'm going to fill these in: 80, 160, and then 320. So a lot of times whenever we're dealing with these types of formulas, we actually don't use x and f of x notation. Instead, we will refer to our x as the n and our f of x as the a sub n. So as I was using that notation earlier, that a sub n, like if it was the first term, it's a sub 1, the second term is a sub 2, and so forth. So in this particular notation, this would be called the term a sub 0 because your n value here is 0. This would be a sub 1, a sub 2, and so on there. So if we're writing a recursive formula, what we're doing is we're looking at what is happening as we go from one term to the next term. So what we can see is happening here, we are multiplying these numbers by 2. So whenever we write our recursive formula, we're going to say that a sub n equals 2 times a sub n minus 1. What we see here is that this a sub n is going to represent the next term in the sequence, and this a sub 1 is the previous term. So if we think about it, for example, if we plugged in numbers for those n's, a sub 2 would equal 2 times a sub 2 minus 1. Well, of course, 2 minus 1 would be 1. So the second term, 40, which we have here, equals 2 times a sub 1, the term that came before it. 20 times 2 gives you 40. And then the same would be true for the next one. This would be a sub 3. So if we look at a sub 3, it is 2 times a sub 3 minus 1, which of course that means a sub 3 equals 2 times a sub 2. So whenever we used to do this with some of the old Math 1 books we had, instead of using a sub n and a sub n minus 1, they used the terms next and now. So to get the next term, you take 2 and multiply it by what you have now is really what this recursive formula is saying. Recursive formulas also typically are going to give a reference term. Most of the time that is either going to be a sub 0, in this case our a sub 0 was 10, or sometimes they'll give a sub 1, which in this case was 20. So just depending on what you're given, you may have those reference terms there. It just tells you where to start, because this formula right here, which is your recursive formula, is no good if you don't know a term to start from. So you have to be given one of those terms to start from. This particular type of recursive or sequence is called a geometric sequence. It is a sequence in which each term is found by multiplying the previous term by a fixed number, called the common ratio. So in the case that we just looked at, that common ratio is 2, because that's the number you're multiplying by each time for this sequence. Let's look at a different type of sequence. This time we're going to look at an explicit formula. A sub n equals 2n plus 5. You can think of this like y equals 2x plus 5, but we're going to use these n's in a sub n notation because that's what we're going to see with recursive formulas. So if we were to plug in 0 here, 2 times 0 plus 5 would give us 3. 2 times 1 plus 5, I'm sorry, that is terribly wrong. This will be 5. 2 times 1 plus 5 is going to give us 7. 2 times 2 plus 5 is going to give us 9. You can start to already see what's happening with the pattern here. We're going to have 11, 13, 15. So this is a linear pattern that we're seeing here. So for this recursive formula, when we're looking for what's happening here each time, we can see this time instead of multiplying each term by 2 to get the next term, we are actually adding 2 to each term. So if we write a recursive formula for this, we would say a sub n. So to get the next term, we would take a sub n minus 1. We'll take the previous term and add 2 to it. And then they will typically give a reference term, so that might be a sub 0 equals 5. Or you're going to see on Delta Math a lot, they use a sub 1 equals 7. Those give you a reference. I particularly like this a sub 0 equals 5 because you'll notice that is your y-intercept for this. And then this number that's being added is your slope. But Delta Math is going to use that a sub 1 quite a bit. We'll see when we get to problems. So this type of sequence where we're adding something each time is called an arithmetic sequence. It is a sequence in which each term is found by adding a fixed number called the common difference. In this particular case, that common difference up here is 2 because that's the number that we're adding each time. If your sequence is decreasing, your common difference will be negative. So those are our two types of functions, recursive formulas that we are going to see. Let's look at some of the questions that you're going to be asked to do for these types of problems. So the first type that you're going to see whenever you go to your Delta Math assignment it's going to ask you to write a recursive formula for the nth term of the sequence. So this is a recursive formula that it's asking for here. A sub 1, whenever you're given a list of terms, it's just that first term. So you'll put 5 for that here. And then for the recursive formula, we're looking at what is happening each time we go from one term to that next term. So from 5 to negative 30, we could subtract 35, but that pattern will not hold to get you to 180. Instead, it looks like here we've multiplied by negative 6. And then we would multiply by negative 6 again, and multiply by negative 6 again. If you ever see your terms alternating between positive and negative, you're multiplying by a negative number. So in this case, we would have negative 6 times the previous term, and that previous term is a sub n minus 1. When you're doing this in Delta Math, there's this little button down here that you're going to click when you need to use a sub n minus 1. So this, we'll notice, multiplying a geometric sequence ends up with our recursive formula being something that is multiplied. Okay. For our next one, we have 2, negative 7, negative 16, negative 25. So our a sub 1 in this case will be 2. It's just your first term. And then we're looking at what is happening with each term. And from 2 to negative 7, that is subtracting 9. And from negative 7 to negative 16, subtracting 9 again, same thing here. So our a sub n is going to equal the term that we have now, which is our a sub n minus 1, minus 9 for this formula. All right. The next thing you're going to be asked to do is you're going to be asked to find a certain value. So they're telling us here that a sub 1 equals 6. They're giving us the formula a sub n equals a sub n minus 1 minus 2. And then we have to find the value of a sub 4. So they gave us a sub 1, it equals 6. A sub 2 then should be, if we use our formula here and we put 2's right here for our n's, I'm going to do this just only on this first one. It means a sub 2 minus 1 minus 2. So that, of course, 2 minus 1 is just 1, so it's a sub 1 minus 2. A sub 1 just means the term before it, so this is going to be 6 minus 2, which gives us 4. And so this equation is just telling us that the pattern each time is just to subtract 2 from that term. So 6 minus 2 gives us 4. Then for our next term, we'd subtract 2 again, and we would get 2. And then for our fourth term, we would subtract 2 again, and we would get 0. So that gives us our fourth term. That's our a sub 4. We would just type in 0 for our answer. Okay. For example 4, we are given a sub 1 equals 9. And our formula here is negative 3 times the a sub n minus 1. That a sub n minus 1 just means the term that comes before it. So it's negative 3 times the term. So to find a sub 2, we would multiply this by negative 3, which would give us negative 27. 9 times negative 3 gives us negative 27. For a sub 3, I might have to grab the calculator here as these numbers get larger. Negative 3 times negative 27 is going to give us a positive 81. Then we'll take that number and multiply it by negative 3. That gives us negative 243. And then a sub 5 would be the next number. So if we multiply by negative 3 again, we'll get positive 729. So that would be the answer that we type in for this problem. Okay. Our next type of problem that we're going to see is we're going to be asked to write a recursive sequence that represents the sequence defined by the following explicit formula. So this is giving us an explicit formula, and we need to go to a recursive formula. So what I'm going to do for this is I'm going to make myself a table. So if I have n and a sub n here, if my n value is, I'm going to start with 0 here, but you could just start with 1 in this case. If my n value is 0, I've got negative 5 times negative 4 to the 0 power. I'm plugging that into this explicit formula. If I plug in 0, negative 4 to the 0 is 1, so I just get negative 5. Then if I plug in 1, negative 5 times negative 4 to the first power, it's just going to be negative 5 times negative 4, which is going to give me a positive 20. If I plug in 2, negative 5 times negative 4 squared, negative 4 squared is 16. 16 times negative 5 is going to give me negative 80. You could plug in another one if you would like. If you do that, if you plug in 3, you're going to get 320. This will be more than enough for us to figure out what is going on here. So they ask for a sub 1, so that's going to be our 20 right here in our graph, because our n value here is 1, so our a sub 1 would be 20. And then for our a sub n equals for our recursive formula, we're just looking for the pattern. So we're looking for what's happening here. We can see that we're alternating between negative and positive, so we should be multiplying by a negative number here. And then negative 5 times negative 4 is going to give you 20. 20 times negative 4 is going to give you negative 80, and so on. So we're multiplying by negative 4. So we'll have negative 4 times a sub n minus 1 is what we'll type into that box there for that one. Exponentials. Exponential functions are going to be geometric sequences. So if you see that you have an exponential function, which we have here, then when you write the recursive equation for it, it's going to be geometric, which means it's going to be multiplied by a number each time. For example 6, we have a linear equation. So we're going to do the same thing here. We're going to make us a table. We're going to say n and a sub n. If I plug in, technically you don't really have to plug in the 0 here, but I like to because it helps you see where those numbers come from. So if I plug in 0, negative 3 plus 4 times 0 would give me negative 3. So you can see whatever value you have here is 0. That ends up being your y-intercept. But if I plug in 1, I'm going to get 1. If I plug in 2, I'm going to get 5. If I plug in 3, I'm going to get 9 here. So that's giving me the pattern that I see here. Whenever I fill this in, a sub 1, here's where your n is 1, so your a sub 1 is this y value here, or well, it's in the y value column. It's actually the a sub n value. So that equals 1. And then if we look at our pattern, so we can write our formula. Each time that we go to the next term, we are adding 4. So our formula will look like this: a sub n minus 1 plus 4. So I want to point out here that this is an arithmetic sequence. It means we're adding a number each time. Linear explicit formula. So linear functions are going to be arithmetic sequences. And you can kind of see here that the amount that you're adding each time, that's the slope of your graph. And then whatever your a sub 0 is, that's going to be your y-intercept. That's going to be useful for the next problems that we do. So on these next problems, we are given a recursive formula, and we're asked to go back to the explicit formula. So I can see here in my recursive formula that this is a geometric formula. I know that because I've got -6 times a sub n minus 1. So remember, for geometric recursive formulas, you are going to see that those are exponential functions. So we should be thinking about our equation here being an exponential. The way I like to deal with this is I like to make myself a table. I'm going to put a 0 here, even though I don't know what it is. I'm going to put a 1. I know a sub 1 is 5 here. So whenever n equals 1, a sub n equals 5. And my pattern is to multiply by -6. So if I'm multiplying by -6, here I'd get -30. Here I'd get positive 180. If I multiply by -6 again, I'd get -1080. So we could continue that pattern on as far as we wanted. But what we see is happening here is we're multiplying by -6 each time. That is going to end up being in our equation, that's going to be the number that's being raised to the power. To find this starting value that's out here out front, we really need to know our a sub 0. This problem gave us our a sub 1, not our a sub 0. So if I'm thinking about going backwards each time here to go forwards, I was multiplying by -6, multiplying by -6. So if I want to go backwards here, I need to divide by -6. So I'm just going to write that as -5/6. So if I divide by -6 there, I'll just get -5/6. You can use the decimal if you want, but some of those will be repeating and harder to type in. So I would just type in -5/6 times -6 to the n power. Because they gave you a sub 1, you've got to go back 1 in that table. Okay. And you can always check this just by graphing this in Desmos or something and seeing if you're getting those same values. Our last one we're going to look at is asking us to do the same thing that was on the last problem. We're going from the recursive formula to the explicit formula. And this time we have an arithmetic sequence because we're adding 9 each time. If we want to think about going ahead and doing our chart, I've got n and a sub n. I'm going to put a 0 here to hold its place. I've got 1, 2, 3. A sub 1 is -4. And then I'm supposed to be adding 9 each time. So I would add 9 to -4, and that would give me 5. If I add 9 again, I would get 14. If I want to add 9 again, I would get 13, and so on. So that is what we're looking at here. Arithmetic sequences are going to give us linear functions. So when we're talking about linear functions, this number right here that you're adding is going to be your slope of your line, and your y-intercept is going to come from wherever your n equals 0. If you're thinking this is x and y, it's where your x-coordinate is 0. So, so I don't have my a sub 0 term, but I could, just like I did on the last problem, go backwards. So to go to the next term, I've been adding 9. That should be a 23. Sorry about that. I'm going to add 9 each time. If I want to go back to the 0 term, I would need to subtract 9, which would give me a -13 there. So, for this problem, my equation is going to be 9n minus 13. You can check this really easily just by plugging in some numbers. If I plug in 0, 9 times 0 minus 13 gives me -13. There's that 0, -13. If I plug in 1, 9 times 1 minus 13 is going to be 9 minus 13. That gives me -4. That's what I have here. 9 times 2 minus 13 is going to give me 18 minus 3, which is 5. That's what I have for this term. So you can see that my formula is correct there. The assignment is going to be on Delta Math. It is homework 1.6 recursive equations. It has questions similar to the ones that you have just seen. Also, while you're on Delta Math, whenever you're looking at those, just a note that there are help videos that you can look at. So if I go, let me go to the sample student page for you guys. So whenever you are looking at, let's say, this question right here, there is a help video right here. So if you are stuck on this, you can watch that help video that will show you how to do some of these problems. I will warn you on these right here. There are some problems that I did not do, like this one with this n minus 1. So it may be giving you more information that you know, but on those help videos should be showing you things that will be helpful. It may explain things a little differently than I do, but that might be helpful to you. You will notice here these questions in the middle where you only have like one question of each one of these. I assigned those specifically to you. Where everybody will get the same problem for those problems. It does mean that if you miss it, it is going to count it wrong, and it is going to cause your grade on that to drop. That is only in Delta Math. Don't worry about that. As long as you have completed the entire homework, you will get a 100, even if you miss some of these here in the middle, because it doesn't give you a chance to redo those. So please complete that for me, and we will go over any questions that you might have in our next